Hey guys, today we will discuss arithmetic and geometric series, and in the end of the video we will see several applications. Set of real numbers where the difference between any two consecutive numbers is the same value is called arithmetic series. For example, every arithmetic series can be given as the first element a1 and common difference d. So second element will be a1 plus d, third element will be a1 plus 2 times d, and so on. And nth element will be given by the formula a1 plus n minus 1 times d. Here we can easily see that sum of the first and last value equals sum of the uh, second from the last value. So we can see that a1 plus n minus 1 times d equals to second value a1 plus d plus a1 plus n minus 2 times d. And now we will use this property to show that total sum of the first n values will be computed as 2 times a1 plus n minus 1 times d over 2. As we know that this kind of pairing, the first one and last one, second and second from last, all of these will give us the 2 times a1 plus n minus 1 times d as the sum. If we take the average in every pair, this will be 2a1 plus n minus 1 times d over 2. This will be total average too if we take the sum of all numbers and divide by n. So if we multiply this by n, we will get the sum of all numbers which are given by Sn. Here we can also see that in total we will have n half pairs. And this number of pairs is dependent on the parity of n. Because if it is even, we will get exactly this value, or otherwise we will have n minus 1 half if it is odd. And as we know that in each sum, the sum is 2a1 plus n minus 1 times d, clearly total sum will be computed by the similar formula. Now let's continue by the geometric series. Geometric series is a set of real numbers where the common ratio is same. Here we are given first element a1, second element will be a1 times r, third element will be a1 times r square, and so on. Nth element will be given by the formula a1 times r to the n minus 1. And here to compute the formula, we will need one factorization. R to the n minus 1 can be computed as r minus 1 times r to the n minus 1 plus r to the n minus 2. The final term will be 1. And we can easily prove that this is correct factorization if we expand everything. We will get r to the n plus r to the n minus 1, all the way up to r, and then minus r n minus 1 plus minus once again r n minus 2, and so on. And final term will be minus 1. We can easily see that all these terms except the first one and last one will be cross out each other, and we are left by r to the n minus 1. So by using this formula, we can see that r to the n minus 1 plus r to the n minus 2 all the way up to 1. This equals to r to the n minus 1 divided by r minus 1. And when we want to compute this sum, a1 plus a1 times r plus a1 times r square, all the way up to this sum, a1 times r to the n minus 1. This can be written as a1 times 1 plus r plus r to the n minus 1. And if we use the above formula, we can see that this can be rewritten once again as a1 times r to the power of n minus 1 divided by r minus 1. Sometimes we need to compute the sum of the infinite geometric sequences, and this is possible if and only if absolute value of r is less than 1. Otherwise, if absolute value of r is more than 1, it's impossible to compute infinite geometric series formula. Here, if the absolute value of r is less than 1, when n goes to infinity, r to the n goes to 0 because the absolute value of r will be very small and this will be very close to 0. So then we can write R, a1 times r to the n minus 1 divided by r minus 1 can be written as a1 times 0 minus 1 divided by r minus 1. And this one can be written as a1 divided by 1 minus r. In most of the cases, in Olympiads or regular questions, we may need this formula about infinite geometric series. Now we will see several applications for arithmetic and geometric series, how to apply these formulas. The first one and the easiest one about arithmetic series is to compute sum of first n values. 1 plus 2 plus da 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 all the way up to n. Here we can see that first element a1 equals to 1 and common difference d is also 1. So if we apply our formula, 2 times a1 plus d times n minus 1 over 2 multiplied by n, we will get 2 plus n minus 1 divided by 2 multiplied by n, which will be exactly n times n minus 1 over 2. So the answer to our question will be n times n minus 1 over 2. Slightly harder application is when we have sum of the first n odd numbers. 1 plus 3 plus 5 plus da 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 2n minus 1. In this case, a1 is still 1, but d is changed, and d equals to 2. And if we apply our formula once again, we will get 2 times 1 plus 2 times n minus 1, which is, we have 2 is the d, and this was a1, divided by 2 and multiplied by n, which will be written as 2 plus 2n minus 2 divided by 2n times n. And we can easily see that this is n squared. So sum of the first n odd numbers equals to n squared. We can easily see this. We can easily be proved by, if you see several examples. 1 plus 3 plus 5, this equals to 9, which is 3 squared. 1 plus 3 plus 5 plus 7, this equals to 16, which is 4 squared, and so on. Clearly, our formula will be correct. And now let's see application about the geometric series. If we are given 1 plus 1 half plus 1 over 4, and so on, this infinite geometric series, we can compute this because the first element is a1 and r, absolute r, the ratio between the two consecutive elements, is less than 1, this absolute value, not equal. R is 1 half, and because of this. So if we apply our formula, our sum will be written as a1 divided by 1 minus r, which is exactly 1 divided by 1 minus 1 half. So this will be 2. Sometimes we may know the answer, but we don't know what is r. For example, in this case, if we know first element was 1, then second one was x, then x squared, and so on. X to the n, and keeps going until the infinity. And we know that this sum equals maybe 2025. How to get what is x? At first, we need to guess that x absolute value will be less than 1. Because as I mentioned, if x absolute value is more than 1, these sequences don't converge, and this will diverge. Which means that x absolute value is less than 1. So our sum can be written as 1 divided by 1 minus x, because a1 was 1, and common difference r was equivalent of x. So this equals to 2025. So from here we can see that 1 equals 2025 minus 2025x. Here we can easily see that 2025x equals to 2024. So the x will be equivalent of 2024 divided by 2025. So this was all I wanted to discuss for today. If you want to discuss any different topics, please write in the comments, and don't forget to like and subscribe my videos.